Okay. We're looking at function notation. So it wants us to state a set of coordinates. So they're given it to us in function notation. The idea of f at x is equal to some value. What is that value? Whatever value is plugged into these brackets here, that's going to be the x value in our set of coordinates. And whatever f at x is actually equal to, that will actually be the y value of our coordinate. So in the very first example, if we take a look, we have f at 0 is equal to -1. Well, that means our x value is 0 and our y value is -1. We could build a kind of a set of a table that might be a little quicker for this. So we can get 0, -1. When x is 3, we get 0. When x is -15, we get -6. F is 6, we get 1, and f is 12, we get 3. Each of these is a coordinate. Okay. While we could build our own Cartesian plane and plot this all out, it might be nicer on a graphing calculator to actually go through this. So what we'll do here is we'll build a table. So we'll go into our table here. We had 0 and -1. We have 3 and 0. We have -15. What's nice about plotting it on the graphing calculator, it doesn't matter the order. For us, it's probably a little easier if we went from x values from least to greatest, because then we can draw it left to right on a graph. But here, let's go to home. There we go. We can take a look. So if we take a look at this, it actually, the question originally says, we'll jump back here, it says, state the coordinates of the following and plot them on a graph. Connect the points. So we've got the coordinates, we have them on a graph, and we're going to plot them. I mean, it looks kind of linear. I'm not sure it is. I can do a quick called linear regression on this. I can say y1. Let me find the symbol. I think it's tilde here. And then m at x1 plus b. I'm going to take away my graph here, and it looks like, oh yeah. So I did a little linear regression here, and it looks like this perfectly fits a line. In fact, the line here is the y value, so the y-intercept is -1, and the slope is 1/3. They've made it a decimal value, but we know that this is just a continuous value that can be represented as a fraction, as 1/3. So we have a linear function. So when the question asks you, determine if this is a function, justify using 2 reasons. One of the reasons this is a function is that it does pass that vertical line test. Okay. No matter where we draw a vertical line through it, it only touches this graph once, so that passes the vertical line test. And algebraically, when we draw it as an actual function, we would write y is equal to write with a mouse at this point here, x minus 1. Algebraically, we can see that this is a linear function. It's actually to the power of 1, and it connects all of the points nicely. So there are 2 ways we can kind of show that this is a function. Create an equation given the points of the graph. Oh, okay, and we use some linear regression to do that. Technically, what we could have done is we could have found this. I'll jump back to this page so we can look at the algebra a little. But we could have found this by just taking 2 points. Since we know this is a linear function, or we estimated that, we could say y is equal to mx plus b. And the 2 values we need to find are the m and the b. M is equal to slope. And slope is rise over run, which is really the change in y divided by the change in x. So I can take any 2 sets of coordinates, especially since we discovered that this is linear, and they should give us the slope. And I'll take the first 2 because they have 2 zeros, which are, for addition and subtraction, usually really easy to work with. We'll take the 2 y values, so we'll take 0 subtract -1 because we're looking for the difference. And for the x values, 3 subtract 0. When we do that, we get +1/3, which is exactly what we found when we had our linear regression. So our slope, m, is equal to 1/3. That's a funny 3. Y is equal to 1/3 x. And then the b is the only other value we need to find. So we're going to look for b in the next step. And again, to do that, since we only have one unknown variable, we can take any of the coordinates and substitute them for x and y, which we'll do x and y here. So the y value in that coordinate was 1. So we'll say 1 is equal to a third, and the x value was 6 plus b. B is what we're going to isolate for. So we get 1 is equal to 6 over 3 plus b. 1 is equal to 2 plus b. And when we bring 2 over, we get 1 minus 2 equals b. B is equal to -1, which gives us a new equation of y is equal to 1 over 3x minus 1, which is the exact equation we use the graphing calculator to also find. So just some ideas when we're graphing stuff like that. Keep in mind what the original question is. It told us to connect the points, which isn't too common. Sometimes they'll just ask you if something's a function without it being continuous. They wanted us to check for continuity, so we did that and we were able to find an equation from that specific question.